or good evening to everybody who is with us live today, depending on where you're joining us from. My name is Elena Nizhnik, and I am joining you here with two very special guests today. And as you guys have seen, the topic of today's stream is a conversation around machine learning. So I'd like to introduce you to Ergeta. Ergeta is actually part of Snap's machine learning team, and Maya Pruitt. Maya is an adjunct professor at the NYU, and she's also a lens creator. So you're in for a treat today. Do stick around until the end, because there are two portions to this live stream. One, which is very conversational around the topic of machine learning and artificial intelligence. And then we're actually going to get into Lens Studio, and you'll see some really cool prototyping. So without further ado, Ergeta, would you like to tell us a little bit more about yourself and your background?
Yeah, thanks, Alina. I'm Ergeta, everyone. Very nice to see everyone here and to be here today. Like Alina said, I am part of our machine learning team, and my focus is on improving SnapML and bringing in new capabilities to SnapML as well. So very excited to be here and to talk to you all about machine learning today.
And Maya, thank you so much for being our special guest today. So if you guys don't know who Maya is, she has been a part of the Lens Creator Network for quite some time, and actually was kind enough to do a presentation at an in-person event at our New York City office, which is where I first met Maya. And to be honest, I was really blown away, because when I watched the presentation, what clicked for me is that a topic that seems so complex, I was able to get super into. And by the time that Maya finished the presentation, I thought that actually I am excited to come home now and try this out. So you were able to take something so complex and something that I think so many people are scared of and break it down into super, digestible concepts, which is why we're so excited to have you today. Maya, tell us a little bit about yourself, how you got started with working in Lens Studio, and of course about what you do at NYU.
Yeah, absolutely. Hi, everybody. It's so nice to meet you, and thank you so much for having me here. I'm really excited to talk about machine learning today. Just a little bit about myself. So I'm a product designer, I'm a lens creator, and I'm an adjunct professor of augmented reality at NYU. And so how I kind of got started in Lens Studios, I actually participated in a residency with Snap, a lens creator residency, where we were talking about how can we make lenses about storytelling or really include a sort of narrative experience. But that actually sort of turned into my first exploration of SnapML, because I wanted to tell this crazy story about aliens coming to Earth and having sort of like being able to find different objects, like a scavenger hunt, and then have that produce the AR content and have these like examples of alien life that are here on Earth. So it ended up again being this exploration into machine learning of how can I start to detect different objects in life and have that be sort of the marker, the trigger point for AR. So that's how I started that. And then throughout, my career so far, I've become an adjunct professor of AR. And so I teach a class at the Interactive Telecommunications program at NYU, or ITP. And we really sort of just do a quick deep dive into the fundamentals of AR, what really makes for AR creation, what do you need to get started, and what are really the modalities or the facilities that exist today. And we use Lens Studio as our tool of choice because it's just such a great entry point into AR, getting started in creation, rapid prototyping, getting your ideas on paper and seeing it come to life using your phone. So that's a little bit about my class.
Awesome. Thank you so much for sharing. So take us away and let's get into what you prepared for us today.
Yeah, absolutely. So today I just wanted to say that, again, like machine learning really it's a vast and deep field of study. And so we're definitely not going to be able to cover everything about ML today, but I'm hoping that this will be a nice kind of intro. And as Elena said, don't be intimidated by it. Really, machine learning is just another tool in your toolkit for AR creation. And hopefully today we'll learn a little bit of how to do that and get you in Lens Studio up and running pretty quickly. So let's start with what exactly is machine learning? So I think it's really important that we actually define more broadly what is artificial intelligence, because machine learning is actually a subfield of artificial intelligence. So artificial intelligence, or AI, is essentially the capability of a machine or a computer to imitate the problem solving or decision making of the human mind. So in other words, really just trying to imitate and mimic intelligent human behavior. And then specifically when we're looking at machine learning, we're focusing on using data and algorithms to imitate the way humans learn. So how does this work? Just kind of like how humans might learn, right? We take a bunch of different examples and we learn to derive meaning from that thing over time. So that's really what the computer is trying to do. We usually start with a data set, and this can be really anything, but most commonly is like hundreds and hundreds of images, let's say, in that data set. And then a machine learning programmer will usually select some sort of ML algorithm that they think is going to work best for what they're trying to achieve. And that ML algorithm is usually a framework or a set of instructions, kind of a mathematical representation of finding patterns within this data set to derive meaning. And over time, this becomes a trained model. And so now this trained model can be given data it's never seen before, use those same algorithms, mathematical representations, and start to make smart predictions. So be able to derive meaning from this new data set based off of everything that it has learned previously. And there are a lot of different ML frameworks. And so here's just a list of all these big scary words of all different types of machine learning frameworks. But I did want to call out neural networks. I think this is a big buzzword for us in ML, and it's probably one that you've maybe heard before. So what is a neural network? This is an example of deep learning, which means that there's multiple layers of these ML algorithms that allow the computer to have even deeper understanding. So just as an example, let's say we want the ML model to recognize different people's faces. So in this input layer, maybe we'll serve it up hundreds and hundreds of images of all different people. And on this first layer, maybe it'll start to do some feature detection. So it'll be able to understand what's the difference between an eye versus a nose versus a mouth. And then on the second layer, maybe it'll start to figure out that features in combination become a face. So when I have, most of the time, 2 eyes, a nose, and a mouth, maybe that is a face. And then on that third layer, it'll start to recognize, oh, well, this combination of features actually belongs to this person's face versus this person's face. And then this output layer can be the actual person's face. And it'll say maybe it's confidence in knowing that this is indeed a picture of Ergeta, or this is a picture of Elena. So that's kind of an example of a neural net. And why this is so cool is because, as you can kind of see, this has striking similarity to synapses of neurons in the brain. And so that's really like the exciting part of machine learning, of there really is this parity of a neural network to the human mind. We are really trying to have the computer imitate what we do naturally in our brains. So I wanted to pass this over to Ergeta to talk a little bit about types of ML models, what we're going to be going over today in the Lens Studio templates, and the training pipeline.
Awesome. Thanks, Maya. So I want to take it, I guess, like one step further and kind of talk to you a little bit about some sort of like key approaches to machine learning training of these models. So, and I'm going to kind of tie it to the goal of this live stream, ultimately for object detection. So I want to start by talking a little bit about object recognition, which is essentially a technique to identify objects present in an image. And that happens to be one of the most widespread applications of machine learning as well. And, there's a lot of different approaches to object recognition. Some are deep learning based, some are more focused on the traditional algorithmic ways of doing it. And like Maya said, for today, we're only going to focus on the deep learning approaches, mainly because those are the more state-of-the-art approaches, and then also they're relevant to SnapML. So a lot of the deep learning approaches for object detection leverage this thing called a convolutional neural network. And Maya already kind of like touched upon a little bit like how a neural net tends to work in its entirety. But convolutional neural networks are basically a type of neural network. And what the network does is that it takes an image as an input, and then it outputs the probability of those different classes with all of those multiple layers in between that do the work of being able to figure out the features that are relevant for that specific task. Now, what is very cool about deep learning is that we actually don't really need to look at the features that are extracted specifically for that task and the data. The neural network essentially is doing that work for us as sort of like a black box. You hear that term a lot in machine learning, but it's just essentially doing that work for us and we don't have to touch it. Now, there's different levels to object recognition, and that's where I think the power of machine learning really starts to get highlighted. There are two main ways in which an object can be recognized, and it really depends on ultimately the context in which you want the object itself to be recognized. So the first one is image classification, in which essentially the model takes in an image as an input and then outputs the specific class of that label. So for example, if an image has a cat in it, like this example here, the model will output cat as a classification label with an associated level of probability with it. So what's the probability that this is a cat? So this model, basically the classification model, is able to recognize that there's a cat in there, right? However, as you can see from the example, it's not really telling you where that cat is in the image, right? So for some ML applications, just knowing the presence of an object is enough to prompt the development of other steps in the application. However, if an application is dependent on figuring out the specific spot in which the cat is present, then we need to introduce another layer or another type of model that is essentially specialized in this task, and that is called an object detection model. So a detection model essentially acts as a sort of like a combination of image classification and object localization, and it adds this second layer to it, which is a bounding box over the classified object. So essentially, like, you're able to classify that there is a cat in there, and then you're also able to localize it with the bounding box, and that becomes like your object detection model. In the example here, you see on the right that there's multiple objects, or I guess like animals, detected in this image, right? And that's because object detection can be used to detect one object in the image, but it can also be used to detect multiple objects in a given image, and that would make the model called a multi-object detector. Now, the object detector, like I said, it outputs a rectangular box right around the desired object or objects. And similar to image classification, this visualization can be more than enough to tackle certain ML tasks. Actually, quite a few of them. We see a lot of developers just kind of bringing it to an end there, and then they use the outputs of that model to continue with their journey. However, having a rectangular shape around the object might limit you in certain situations if you're specifically looking to do any type of application or transformation on the object itself, when the shape, the size, and the area of the object may be important components of that flow and that experience. And so if any of these criteria become important, then there's a next step to object detection, which introduces this pixel-wise masks overlaid on any given object, which is then called image and object segmentation. And so the beauty of this approach is that it basically introduces a more granular representation of your object of interest. And I do want to point out that just because you can go to this level of granularity doesn't mean that is always the best approach. So I like to think of it as like, while the breadth of neural networks is pretty vast, sometimes picking a highly complex model to tackle a very simple task sometimes ends up being an overkill. So especially if you're not going to use all of these components that the model has to offer. So I'd love to kind of like give you guys sort of like a way about or a framework of like, how do you pick between the different approaches? It ultimately depends on your use case. So a few things to keep in mind as you're kind of like doing this assessment is, what are you trying to solve for? What level of information you want to extract from the image for your task? And then ultimately it depends on how you want to train that model. So what kind of training data do you have at hand that you are inputting into this neural network so that it learns from? And those will help you sort of like guide that direction in which you want to go, how deep in terms of like training these models. So yeah, that's kind of like an overview of the training pipeline. And ultimately, like with SnapML, we definitely take care of like that part of like being able to bring that model into into Lens Studio. And then we even provide you some really cool starting points for training code that you can use to be able to like either train your own model or even just like plug in that model into Lens Studio. And then Maya's going to go over that for sure in this live stream. But yeah.
Yeah, exactly. And just to add, today we are going to go through image classification versus that object detection. So you can kind of get an example of both, because that's a great point that Ergeta brought up, which is that sometimes you only need a certain level of detail. So depending on the experience you're trying to make, what model will best serve that purpose. And so you'll get to try 2 examples today, which will be cool. So again, just really thinking about how can we leverage machine learning for AR. So what is machine learning in the context of AR? So what I kind of mentioned before is the modalities of AR, right? I call these the anchors between reality and virtuality. So these are the points of contact between the physical world and your virtual world that you're creating. So they're the triggers or markers. Examples of this that we have today that are really robust, and you can go into Lens Studio and make experiences right away for all of these different modalities, is an image marker, for example. Or we could have the camera look at faces and track faces and the way it's moving and apply augmentation to that. Or we can also have the camera recognize bodies and track bodies and put AR on top of that. And then lastly, we have the world space or the environment, and the camera can even recognize a ground plane versus a wall surface, and you can really sort of craft all different experiences based on these robust modalities. And they all really kind of have their own affordances, right? You're probably going to have a very different experience when you're tracking a 2D image versus tracking the face. And so it's just sort of to kind of think about how do we categorize the thing that the camera is looking at in real life to then add augmentation to. And so what's so exciting about ML and what we were looking at, this ability to classify, to detect objects, to then even segment, is that we can really expand the scope of AR modalities. So for example, maybe I want the camera to recognize a mug, this custom object. Instead of it just being tracking an image of this particular red mug, I could train a machine learning model to be able to recognize all different instances of a mug. So it could be, regardless of its materiality, its shape, its size, its color, even the angle maybe of the mug, and we can still have the camera know that is indeed a mug. It can classify maybe what type of mug, if I wanted to know like different materials or something, or in the case of the object detection, it could draw a bounding box and say, hey, I know exactly where this mug is in space. And so this is an example of the same model that we're going to use today in one of the templates running on mugs. So you can see it's able to detect where the mug is in space and put a bounding box around it. So it's recognizing it is a mug and also localizing it in your camera frame, which is really cool. I just wanted to show this graph as well and pass it over to Ergeta to talk a little bit more. In addition to expanding sort of what you're able to track, you are then expanding what you are able to do with that information. So I'll have Ergeta talk a little bit more about this.
Yeah, so basically echoing what Maya said, like if we're thinking about the modalities of AR, right, and kind of like bridging that gap between reality and virtuality, like ultimately it boils down to like augmenting our surroundings, augmenting people and yourself, and then augmenting those experiences, right? And when you think about exactly like what does the augmentation of each of these components actually mean, it could be a lot of different things. It could be recognizing specific objects. It could be localizing those objects or people or environments. It could be tracking certain things that are interesting to overlay additional information on, transforming, substituting, enhancing, like all of these things essentially that are key pillars of augmented reality as a technology itself are things that for the most part are actually driven by machine learning algorithms and models. So you can see how seeped into the whole augmented reality space machine learning ends up being, even though sometimes we like, and you see this a lot in Lens Studio, like we are able to abstract it in a way that it's very easy for people to understand and kind of like work with it and get started with it. But under the hood, there's a lot of machine learning models that are doing a lot of the work and are able to get to all of these different components of the augmentation that we care about. So this is like, I want to emphasize with this slide that this is the power of machine learning, and this is how it actually connects to augmented reality. So I want to encourage everybody that is thinking about machine learning is that it's a tool that it enhances these experiences, and it's also highly ingrained into the overall space itself. So
absolutely. You've probably been using ML in a lens filter in so many different ways. Like my favorite one is the disgust and the shook ones, where you just like have that permanent terrible expression, but that's ML. Or, you might see like, there's just so many examples. It's really cool to the cartoon kid, for example. So there's experiences that you have probably actually been using machine learning for that isn't even this, object detection necessarily, but it really is ingrained in Lens Studio and Snap. So to just kind of prepare us a little bit again for how this is going to work in Lens Studio, wanted to just remind us real quick of how ML is working. So again, you have this data set, ML algorithms, a trained model that gets unseen data, and then it's able to make predictions. So this is taken just from the Lens Studio documentation about ML. Same thing, there's going to be training data that's happening, some sort of training process, and there will be an output of a file type, which is containing the ML model. So usually a .onyx or a .pb, and that can be imported into Lens Studio, and it'll be housed under an ML component. And that's what's going to start running the ML in your experience in Lens Studio. And so the camera input then becomes that unseen data. So you're serving up different frames of your camera feed that are going to be now put into the model, run through the model, and you'll get an output. And that output, whatever it is, depending on the model, is what you can really use to create your augmented reality experience. So that's just sort of a brief overview of how it's going to work in Lens Studio. Just wanted to throw up here, we're excited. It's very important when you're working with these things to just like always remember, where your information is coming from. And I encourage everyone to, if you're really interested in this stuff, just go deeper, keep learning more about it. It is endless and you can get really specific, but I hope this was a good overview. So that'll bring us to our Lens Studio demo. But Erica or Elena, did you want to just add anything before we jump into the main event here?
I don't have anything to add. I just wanted to say that I've been asking our viewers, and thank you everybody for being here with us. We have so many folks that are excited. And actually, I was chatting with William about what projects they have been making using SnapML. And they mentioned that they've used something for style transfer, which is such a great example
yes.
of the use of ML, right? And I think that many people don't think about style transfer as actually being powered by machine learning, but that is in the essence of the simplest things that are being done all behind the scenes, that require the least amount of lifting and actually do show the power of machine learning. But here's a kick. Will mentioned that their next project that they'd love to do with ML is to point a camera to any plant and the camera give you the name and details of the plant. So I think that Will specifically is in for a treat in today's live stream, the technical portion of it too. But I'm just going to remind all of our viewers, please don't be shy, ask any questions you have. Two stupid brains here that'll be able to answer your questions. So, don't wait until the end. If you want to ask anything as we go, please go ahead and do so. And Maya, we're excited to see the Lens Studio demo.
Yeah, absolutely. Okay, awesome. Will, you totally read our minds today. We're going to do something very similar. And I wanted to use, all the templates that we have available to us today so that really, if you wanted, you could follow along and we can get started right away without having to bring in too many new assets. So hopefully you can just kind of open this project. So go ahead and go to the MultiClass Classification project, and we'll just give Lens Studio here some time to open up. If you're not familiar with Lens Studio, there are tons and tons of templates that describe really all sorts of different features that you can do in the platform. Anything from working with physics or adding 3D objects to a face or to a body. So really, there's a lot there for you with a lot of different examples, and it's a great place to get started. I hope that this will load. This is how you know it's live, everybody. There's no magic here.
Exactly.
We're just doing it. I'll talk a little bit as it's loading of what you're going to see. So the multi-class classification, right? If we were looking at that diagram that Ergata made, is that it is able to take see a bunch of different types of flowers. The model in this particular, there it is, recognizes different models and it outputs its confidence that it is seeing a particular flower. So it's classifying based, right here, we can see in the preview, this is the multi-class classification template in Lens Studio. It'll open up with a preview. It has a bunch of different videos of different flowers, but we're going to use the hibiscus today. And what you're seeing here is that the camera is taking in this, the feed, and it's outputting, the model's running and outputting and giving you kind of these top 5 guesses of what class this flower is. And it's showing here that probability that I mentioned. So this is saying it's about, 92% confident that this is indeed a hibiscus flower. And then this is just UI or user interface elements that we've created in Lens Studio to display the output of the model when it's running. So I just wanted to kind of show us a little bit of what's going on in here. So here in your objects panel in the template, we have basically the way that the whole lens is set up. So if I click here on the multi-class classification, in my inspector, I'm going to see more information about this. So the multi-class classification is a script, but what it's doing is it's holding the ML component. So this is our model. This is the model that's able to classify different images of flowers. It has another script that shows the labels or what the names are of all of those classes of flowers. And here's just some other details of like the threshold. It sort of represents the sensitivity or how well it's going to be able to classify those things. So you can make that more or less sensitive. So if you wanted it to be super, super accurate, you might not always get the results right away, but it would, know for sure that it is the thing that it's looking at. But you can also decrease that threshold, and then that means it'll probably give you results faster. It just could be wrong. So just something to think about there. We'll just leave everything as the default. Also just wanted to show top K again is like how many of the classes do we want to say? It's top 5 guesses, but you can change this number if you wanted. And then we also have some features here that will use behavior. And so what we're going to do today with this lens is just try to recognize the hibiscus flower and trigger something to happen. So we'll bring in, it could be really anything, that's up to you as the creator. Today, we're going to bring in just a GIF or a GIF. I never know which way to say. Put in the chat how you pronounce it. And then we'll just have that spawn based off of classifying that it is indeed a hibiscus flower. So let's go ahead and get started with that. I'm just going to turn off the blur a little bit, or let me actually describe in more detail here what's going on. So on the ML component, this is really important. In Lens Studio, this is where you're going to be able to put in a model, and you can put in any model that does all sorts of things. There are actually, if you go to the asset library and you go to SnapML, there are actually a bunch of machine learning models in here that you could try swapping into your Lens Studio projects and kind of experiment. If you kind of hover over this eye here, it'll tell you the things that it's able to detect. So if this is the food and fruits one, it can see all these different things, anything from a banana to cake. This is a household object one. This is animal detection. And then we have some other classifiers like, is a person wearing a mask or not wearing a mask? So you have a lot here that you can kind of just play with from the get-go. And so you would import that model, either that file maybe of something that's been trained outside of Lens Studio, or you can go from the asset library and that would pop into here into the model. And what this is telling you here is what is being inputted into the model. So what I think is cool about this is you can really just see the input and the output, right? So the input is, we're saying it's the screen crop texture. So this is this actual square box. And why this is kind of an interesting thing to know if in machine learning is that often when you're doing image classifiers, you kind of want a baseline of all those images to be the same, right? So when Ergata was showing the classification of the cat, it probably learned cat pictures by seeing a square image of cat with cats always kind of in the center, right? And so that just sort of helps it learn because it's getting the same style of input almost. So we're mimicking that here. With the screen crop texture, we are bringing in just a square frame from the camera feed. And so really this model, I think, is like it kind of needs that flower to be in the center of that square frame, and that's how it's going to have more confidence in recognizing what it is. And then the output here is just telling us that we have 103 different channels or 103 different classifications. And so where we can actually see that is in this labels script. So if I go into my scripts folder in the resources panel and I open the labels, is it in here? There it is, sorry. I was looking for labels, but it is called flower classification labels. So here you can see these key value pairings, right? So it's telling us basically the channel and what that name is. So if we kind of go down the list here, we can see channel 48 is hibiscus. And then they can kind of just see the pairings. The reason this is important is because we want to basically tell Lens Studio, we're going to use the behavior script today to say, what label are you looking for in order to produce our effect? So let's just kind of go through the other things that are in this scene. The perspective camera, that's the camera that is like the rear-facing camera that's like going out into the world. We have this Gaussian blur effect. That's what's giving you this here. So we don't necessarily need that. I'm just going to turn it off for today. And then the orthographic camera, this is anything that's like on the surface or on the screen for your experience. So this is what is holding the this UI that's showing us what is happening in the model. And we can see here, the Lens UI has a image that is this screen crop, and it's showing text. And it also is showing there's a script here that's creating this grid to show us this progress bar with the labels and their probability. So that's just what is lying on the surface of your screen to tell you what the model is seeing. So today, I'm going to just actually turn this off because I kind of want to start from scratch. We're just going to show this video on loop here of us finding this hibiscus flower. And I want to make this hibiscus flower make a hummingbird GIF appear. So how I'm going to do that is if I go here to plus and I go to helper scripts and go to behavior, I can bring in a setup for making interactivity happen. And if you are familiar with Lens Studio, I think the behavior script is probably my favorite thing in the whole platform because it just really helps you so easily get started in making something interactive. This is where you're basically going to say, what is the trigger? It could be touching the screen. It could be seeing a face. It could be smiling versus, raising your eyebrows, and then make something happen, make a response. So in this case, we want to say, when I have found this hibiscus flower, make something happen. So if you'll remember when we were in this multi-class classification section, it's already been scripted for us in the template to use the behavior system within Lens Studio. So there are already custom triggers kind of created for us where if we use this onFound prefix and our onLost prefix, we can make things happen when the flower is in frame and when it's not in frame. And why the labels is important is we just want to make sure that we're using the same, using it exactly as it is listed here so that it can be referenced by the script correctly. So let's go to our behavior script. And I want to say on custom trigger, give it a second to load. The trigger name is going to be found _. That's that prefix that we have that's already been scripted in the template. And then I'm going to write hibiscus because that's what I'm trying to find, if I can spell. And my response is I want something to happen. So let's set up what we want to happen. I'm going to go ahead and just bring in a screen image. I'm just going to scroll down for us, but it's just easier if I type it in. And if I go to my scene panel, screen image, here we go. So this is just a default template. And if you're seeing some of these other things, these are actually the loader and hint, which we also are using. I'm going to disable them for now just so that we don't get confused. But these are really important for whenever you're making a AR experience. Just always keep in mind that you kind of have to think of the whole entire UX of it, right? The whole user experience, because sometimes there's going to be people using your lens and they won't exactly know what to do or what's happening. So Lens Studio is always really good at showing us kind of that end-to-end experience. So like when someone opens your lens for the first time, you should probably have some indication of what's going on, so the user is not completely blindsided and like they're not going to know what's going on unless you tell them like a hint or something's loading, right? So that's just showing what that is. But for now, we'll just turn off. So here is my screen image, and I'm going to go ahead and I want to bring in a GIF of a hummingbird. So this could be on your side, just really whatever you're interested in, any sort of image. I'm going to bring in my hummingbird. There it is. And you do this by clicking plus in your resources panel, and then you can import anything. It might take a little bit to load because it's a GIF is essentially a 2D animation, so it's loading in every single frame. All right, and then here is my screen image. I'm gonna just go ahead and drag the hummingbird into the texture field. And so now here I have a little image of my hummingbird. I'm gonna just move him a little bit, hopefully kind of make him look like maybe he's trying to eat the pollen. I don't know what hummingbirds do, but be on the flower a little bit more visibly. All right, so that's it. We have basically everything we need now to make the thing happen. So in my behavior, again, I want to say that when I found the hibiscus, make this hummingbird appear. So for here in the response type, I'm going to click set enabled. And I'm actually going to, let's rename this so we can keep track of it. Hummingbird. All right. In my behavior. So now I'm going to drag the hummingbird into my target. And so I'm saying again, when I'm found the hibiscus, I'm going to make the hummingbird appear. And then just so we can really see the effect, I'm going to copy and paste this. And I'm going to say, when I've lost the hibiscus, disable it or make it disappear. I'll click that to disable. All right, and I can actually disable it here because the script is now going to take care of this for me, so I don't have to have it enabled in my scene. Sorry, there's a little bit of a lag. All right, so let's see if it's working. There we go. So it sees it in the center of our camera feed. When it goes away, the hummingbird goes away with it. And that's it. That's just like a super, super quick way to start using ML to recognize different things and make something appear. And you could change this trigger to be something completely different. You could maybe like animate this in. It could be a 3D object. Like that is up to you as the creator what you want to do. But I think this is a really great way to just start thinking about what is the camera seeing and what do you want to make happen once it's seen that thing. So that is the MultiClass classification. Elena, Erica, did you want to add anything? Also, feel free to jump in at any time while I'm going through this if you have any extra thoughts.
Thank you, Maya. Nothing to add from my end. I just feel like you really are highlighting the simplicity of things. And I don't want to, say that this is like super, super simple, but I do want to say that a lot of the things that you could be using right now, are sort of done in such a way that Lens Studio takes care of a lot of these things for you. Just like you were talking about the helper script, right? Like, oh my goodness, how many lenses have I made that I use the helper script for that create interactions that you don't have to then go and create from scratch, but just give it a go. It could be a lot quicker to get started than you think. So machine learning is not as scary as it can be. Of course, Argetta did say that you could go all the way out and train your own model.
You definitely could. That would be part 2.
Exactly. That'll be part 2, and you probably would also want to take Maya's course at NYU too. Right? But for now, it's just sort of like, thank you for showing how very, very quickly you can achieve something and actually use the lens. Excited.
Here, I just wanted to swap the video so you can see, right? It's not working because it doesn't see a hibiscus in this video anymore.
Yeah.
So it's not going to work for these other ones because we haven't told the lens to do that experience. So just an example. For ML too, just definitely like always bring in different preview videos, really make sure that it's working in different scenarios, try different images. You can always add your own previews to Lens Studio by going to this plus from files, and you can bring in still and video images to test your experience. And then of course, always preview it on your device. So MultiClass Classification. I also wanted to just point out that that very first lens that I ever made of my crazy alien story, this did not exist. And if this existed, oh man, that would have made my life so much easier. So just saying, it's really cool to see how Lens has really grown, and now this is really putting the power of doing this into anybody's hands, which is really exciting. Okay, so go ahead and save this project if you want to reference it later. I said don't save, which I know is scary, but it's okay. I've done this a couple times. Now we're gonna level up. And we're gonna do the multi-object detection template instead. So again, as we were kind of looking, right, we have the ability to do classification, but with object detection, we can now localize where that is in space. And then what is really cool about the multi-object detection is I can tell where a bunch of different things are, know the difference between them, and then know exactly where they are in space. So this one, again, it might take a little while to load, but this one is a model that distinguishes different berries. So we're going to work with that today. We'll do a couple different things with the ML model.
If I were to chime in here, well, the one really cool thing about the multi-object detection model is, and template in general, is that we also provide the training code behind this model, so that if you're interested in retraining this model with other data sets outside of berries and things like that, the only thing that you have to do is just swap out the data set and then retrain that model with a new data set, and then it should work. And you can just pop it into Lens Studio and get started with it. And that model is trained on quite a state-of-the-art kind of architecture, which is really cool, which means that the model performance and level of computation that is done, like, it's pretty robust, which is why, like, you see, like, in the image reference here, in the video reference here, that, like, it's able to detect pretty accurately the different types of berries. So for anyone who's interested in kind of diving into it more, it's based on a YOLO v7 architecture. I'm not going to go into much detail on what that means, but just look it up. It's a pretty powerful model. So
do you know what YOLO stands for, anybody? It's not you only live once this time. It's you only look once, which is kind of cool.
We should let our audience take a few guesses, because I'm figuring we probably would have had quite a few of the only ones. But
true. I jumped the gun because I got excited. Yeah. It's really powerful, and I didn't realize that, so that you can just go ahead and start training using that framework already. So that's super exciting. That is the next thing that you can really take your Lens experience to, like, total customization. Mm-hmm. Okay, so let's dive into this one. Again, this is the multi-object detection template in Lens Studio. So you can use this and get started right away. Let's just kind of see how it's set up once again. So we have our ML controller script. We can see the ML component here with the model, which is this berries detection model. And the input texture, instead of it being that screen crop, right, that was kind of creating that square frame, this time it is the whole device camera texture. So that means the entire camera feed. So that's how we're able to see, tracking that's our detection, rather, that's coming all the way up here across the entire screen. And then, if you changed your device, it would be the whole feed in whatever size that is. Another thing wanted to note is that the setup of those labels for the different classes is a little different in this template. So here we're seeing it here. We have 4 channels labeled here in this array. And here we're seeing the the labels of what those classes are. And enabled just means whether or not we want the camera to be looking for that particular class. Again, we have here some different thresholds. If you go on to the Lens Studio documentation, it'll tell you what each part of these parameters mean. But again, it's sort of thinking about the sensitivity, how accurately do you want the camera to be able to detect things, and then also what to do if it kind of sees two sort of at once. Should we just draw a bounding box over the one? So that's what's kind of happening here. So different parameters that are just sort of dictating how do you want the model to run in your Lens Studio experience. So we have the camera, obviously, that's able to look at things. And again, we have on our orthographic camera some just different features of this is what's actually our augmented content. So the way that this one works is if I go to the detection controller, there is an ability here on this script to take an object and copy it so that it'll put that on every object that it's detected in the feed. So here we're saying that we want to copy this colored rectangle. So that's what you're seeing here. So let's just take a quick peek at what the colored rectangle looks like. So this is a script that has a screen image of this rectangle with this outline and some text, which is showing, again, that class label and the probability. And then on this, there's also an array of color values. So that basically what we're saying in the script, and let's go ahead and look at that in more detail. Set color example here in the script is based on what area we've detected, change the color of the frame. So let's see if I can give you a decent view of this.
And Maya, while you're looking into that, we have a question from Haval. Haval is wondering whether or not this can be applied to large bodies and objects, for example, planes.
Yes.
Yep.
Obviously, you'd have to be standing quite far from the plane probably to get it all in frame. But go ahead. I didn't mean to cut you off there.
Yeah, I think it boils down to what training data you're using to train the model, right? So like if you have images of planes from far away, so they're like smaller, and you have like a full body of the plane, then you would be able to detect those if you are kind of like taking a distance from the plane itself. If you're looking to detect certain parts of the plane, that would be another ML use case. So you would have to have a training data set that will be able to identify the different parts of the plane, so like the wing or the front of the plane and things like that. So, but yes, you could use a very similar model, swap out the data set and go for it.
Thank you.
So just wanted to show here. So what's happening on this set, the color example, is here is where we are kind of telling what's going to be in the GUI or what the parameters are. So if I click on colored rectangle real quick, you can see kind of a one-to-one here. So this is saying we want to have a field for inputting text, a field for importing a mesh visual or an image. And then also we want an array of where we can decide what the colors will be. And then we have some other functions in here that are doing important things, like this one here is making sure that every time we have an instance, it is a new material. So there's no shared materials. It's just each object has its own. So that's what this does here. And then basically the main thing is this function right here, which is on every detection telling us what we can do with that information. So specifically for this script, we are saying that when we are detecting an object, depending on what its class is, its detection index, or again, when we saw here real quick, where is it? Right, depending on this index, match that to our index here of our color array, and then you'll know what color you want a blueberry to be versus a raspberry versus blackberry. So that's what's coming here. We are just setting the material color. So you grab that by doing material.mainPaths.base color with whatever information we're getting from the model's detection. And then it's also doing that to the background color of the text. And it's also doing that to tell us what label we want it to say, as well as the score or that probability number. So that's what this whole script here is doing. I did want to show you that since this is set up really nicely for this object to copy, we can just put different things in here and see how this will change. So I like starting with the colored rectangle because it really is exactly as we were describing earlier, of just showing you that detection and also the localization of where it is on the frame. But this could really be anything. So there are examples in the template already. So if I bring in simple frame, for example, now it's just going to draw simple frames around. And then also there's something called photo frame here. So if we drag the photo frame into the object to copy, now we will see this kind of little Polaroid effect here, also showing us the labels. If you're noticing that it looks a little jittery, and I'm not sure how it's looking on the stream because it's a little laggy for me, but if it's wobbling a little bit, there are some parameters here to just kind of improve that. So you can click on match detections and some smooth coefficient here, and that'll kind of make it feel a little bit more seamless. So again, just some more built-in parameters of how you can make the look and feel be exactly what you're thinking. So that's there. So I just wanted to show you though too that now we can just put anything. So let's go ahead and just bring in another screen image. I'm just going to bring it up here. Oops. Not as part of that, its own object, just so we can keep track of everything living under this object. Where to go? Screen image. Object to copy. All right, and I'm just going to call this example. And to make this easy for everyone, let's just use what we have in the template. So if you see down here, we actually have something going on here, and I'm going to talk about it later, but it's have these really cute little illustrations of fruit, and it's actually counting how many it's seeing in the space. So let's just use those for this demonstration. If you go into the textures file, you can see those images. Which one do we like the best?
The raspberry looks nice, I guess. Yeah.
Okay. So for example image, I'm going to drag in my raspberry into the texture field. And what I'm going to do now is I'm going to put this raspberry illustration on every single berry that I see in the scene. So how do I do that? I go to detection controller, object to copy. Let's bring in the example that we just made. Give it a little second. Now everything is augmented to be a raspberry, even though it's not in real life. So we've already made just like a quick example of now we can add our own content like perfectly to the size and spatial area or where it is in the frame with this new augmentation. And so you can really see how robust this is because this raspberry is matching the size of the strawberry, which is really exciting. And it's mapping it to every single one. And there's also a nice little effect there that lets it pop in. I'm just gonna make this a still image for a little bit to show our next thing. So, I mean, this is cool, but I think it would be nice if we could actually make everything match. So can I make sure that my augmentation is specific to the particular object in real life? So instead of making raspberries appear everywhere, it'd be really cool if I could make strawberries appear on strawberries and blackberries appear on blackberries, etc. So what I'm gonna do is we're gonna dive into code now. So like I said, we are leveling up. We got to just use the behavior script, but this time we're gonna kind of do a little bit of our own scripting. But I am not a programmer by profession, so don't worry. I will try and keep it as simple as possible to just get us sort of into the idea of it all. But I'm gonna basically borrow a lot of what we have in this set color example script to make our own. So actually, if I go to the scripts folder, there is already an example in there. So, Lens Studio is like, you're probably going to want a script here. We'll get you started. So we're going to go ahead and click on that. And this is editable. You can also, if you are a programmer and you want to, use another text editor that you're more familiar with, like Visual Studio Code or Sublime, you can actually do your scripting there and bring it back into Lens. You don't have to use the environment. So just a heads up there, whatever's like kind of easiest for your workflow. So here is the example. It's already just kind of giving us the things that we need, right? Which is basically being able to run the model and upon detection of an object, do something. So I do want to kind of follow, though, this set color example where I'm able to put parameters into my GUI so I can have a little bit more control. So what I'd like to do is create basically this same scenario where I can select an image, and then have an array of different textures. So I want to make this different images that I can swap in a different texture depending on the class. So the way that we're going to do that is on my example, let's take in from the colored rectangle script, this mesh visual parameter. And let's make sure this is working by, I'm just going to add this script that we're working on to the object that I have here. So this example image, I'm going to click add component, script, add script, example scripts, example. You can also just drag in the script, that's showing you that I'm going to have that tree hierarchy if it's helpful. Just so that I know that it's attached to this object. And so I want to make sure that I'm seeing this thing in my inspector panel. So another important thing is when you're editing a script, there's going to be this little dot that appears and that'll tell you if it's unsaved. So you always have to save in the script in order to see, what you're working on reflected in the inspector panel. So make sure you save. The dot will go away. And now I can see that I've added this parameter to include an image. In addition, I want to do an array of textures. So just give me 1 second because I have my reference here and I just want to make sure I'm following it. All right, so similar to what it was here, right, is creating an array of something. I'm going to do that, but with an array of textures. So how I do that is input asset.texture, the brackets, so that I'm indicating it's an array. I'm going to call it texture. And then I'm creating a variable called texture that is going to be set to this script texture. And let's make sure that we're seeing that. So here we are. Here I have my image parameter, my texture array. And just like the color example, and the fact that we are able to identify 4 different classes, I'm going to put 4 different textures here. So let's set this up kind of how we want to. I'm also going to just turn off this object counter so we can just focus on what we're doing. So what I'd like to do now is just bring in that example image is fine. That'll be like the host of it. And we are going to use this array to swap the textures. So let's do the same cute little illustrations we had, but someone is going to have to remember the order for me of what the model class is. So blackberry, blueberry, raspberry, strawberry.
We're just going basically in alphabetical, right? Blackberry, blueberry, raspberry, strawberry.
Oh, so smart. Perfect. Okay, great. So now I have this set up to have the textures swapped in. And now I need to tie this to the function so that it's actually reacting. So I have my parameters and basically created the shell of what I want to happen, which is take this image and swap in this texture. But now I need to write the script to actually do that. So we want that to live in this function of updating the texture. Oh, and one other thing I forgot is I do want to make sure that we're doing that same material situation, just in case. Example. And this is where I'm going to put that script to happen. So we don't get confused. Let's put it here, or sorry, rather those instructions to set the color example. So kind of similarly, we're going to set the material equal to this texture array that we've made using the detection index. I'm just trying to save myself time by copying and pasting. But what it's going to be is instead of material main pass.base color, I want it to be base text. And I'm going to use this texture detection index. Yes, I feel good about this. One thing I did want to note is, so how do you know kind of what property to reference? If I go to a material, let's see, do we have a good example of a material? Yeah, simple material. So here, just in my resources panel, if I click on any of these materials, right, there is a base texture But you can't just call it texture. You can't call it the name of the thing. You have to make sure that the script is referencing it properly. So if you actually hover your mouse over the label, you'll see what the property is to be referenced in the script. So that's how I knew that it's going to be .mainPath.base text, because that is how the texture is referenced. So that's how I knew to do this. All right. So then we can just click save. I'm not really doing this reset stuff, so I'm just going to eliminate it for now. It would be good to have in the future, but just for the purpose of today. And so already you can see, just like that, now it is putting the image of each thing corresponding to the right class. So again, just this is a great way to learn, is just use the template and kind of like be creative in sort of like the existing parameters, see what you can do with it, and learn and try different things. And something that's always really helped me is to just break it down into the smallest thing possible. So I knew when I saw this, I was like, this would be really cool if I could do this, 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 and this. And I was like, but wait, first, I think I just need to learn how to make an object appear on all of the berries. Okay, now I want to know how to make an object appear for a particular berry. So that's just what we're doing here, what I'm trying to walk you through today. So this is cool. So now we have the berries kind of corresponding to what we want them to be. It works with video. It'll work for different previews, just like that. So very cool. We know that it's working, which is exciting. So the next step that I was thinking was, we have this, I'm just turning and disabling a couple things here. We have this object counter, right? So what is cool about this script already, this template, is that there's another script here that is taking the information of the model and counting for you and telling you how many of each berry it's seeing. So I was thinking, what if we could detect the berries and say, well, hey, like when I have a serving size of berries, let's make something happen. Maybe we can make this a really educational experience. So my goal now is, I want to say, when I have 12 blueberries, that's a serving size. I think it's actually technically more, but for the purposes of demonstration, because there are 12 berries in these video previews, when we see 12 berries, serve up some nutrition facts about that and tell us that it is a serving size. So how we're going to do that is, let's use the object counter script that's already in here. So here is the object counter script. Okay, also real quick, and this is just the designer in me, I just want to make it a little bit easier for us to see those images. So let's just do that real quick. I'm gonna kind of give the berries down here a background. So I'm sorry, this is a bit of a tangent, but I just think it will make it a little bit easier for us. I'm gonna put this behind here. Screen image. Gosh, sorry if it looks a little finicky. It's just quite laggy on my end. So I'm just making this a background.
I think you're bringing up a pretty important point too, right? Because sometimes functionality isn't enough to just delight your, whoever is experiencing the lens too. So some of these little details can really make it pop, right? So, keep in mind that you can do a certain amount of things by making really small changes and really make the end user, a Snapchat or a client, right, when you're pitching to them, experience the lens in a much fuller way. So yeah, don't just think about, okay, so it functions and therefore it's good. Like, try to delight people with your AR lenses.
Exactly. Cannot agree more. So yeah, just again, like I'm all about sort of fast prototyping. So if there's stuff in Lens Studio that I can just use to get myself up and running, I just try to keep everything in here. And then until I'm like really happy with my assets that I've maybe created outside the platform, and I bring them in later. So I'm just bringing in this PBR material because I want to borrow his base texture. So in this background, I'm going to bring the base texture now that I know came in right here, which is just this gray box. And I'm going to put that on the background. Put that in here. All right, I'm going to stretch it. Okay, so now at least I can kind of see these a little bit better because I have something behind them. You can get fun with this stuff. Make it really cool. Whatever works for you. Okay, So maybe the gray was fine. Okay. It's a little dark in contrast. Always make sure you're thinking about ADA accessibility. But the purpose is I can see the counter a little bit better just doing this because we're using the same sort of assets multiple times. And I just want to make sure it's very clear what we're doing. So I have this counter now. That was a small digression to enhance the experience. And now what I want to do is I want to say, hey, now that I'm recognizing that there's 12 blueberries in this space, trigger something to happen. So let's use this object counter that we have, which is this script here. Go to my script editor, open object counter. So same thing, already in here, there's a lot given to us. The main thing that I want to kind of point out is that we're doing a lot basically of saying count per class. We're saying like when you see a blueberry, where you have a whole for loop here going where we're increasing this counter every time we've detected a blueberry, increase the counter for that class. And we've done it for all 4 classes. So for all 4 berries, we're saying increase the counter every time we recognize a berry or we detect a berry. So I want to kind of use that to my advantage and sort of just like very simply say, well, hey, if I have 12 blueberries, maybe I can use the behavior script. I can trigger behavior. So, you know, as more beautiful coders, I would hope that you won't just hard code what I'm going to do and you'll make this like a really beautiful function. But for the purpose of demonstration, we're just going to hard code this and say, if I have 12 blueberries, make something happen. So I'm going to say if count per class, for class 1, I believe is blueberries, right? Blackberry, blueberry. Okay, 1. Perfect. Then I'm going to say, if that is equal to 12, the count is equal to 12, then do something. So let's just test that this is going to work first by printing to our logger. So this is just always a good way to test that your functionality is working. So there are 12 blueberries, and you can make that say anything, but that's what I'm going to say. All right, and save that. And am I seeing it? There it is. There it is in the logger. So here in the logger panel, the logger panel is showing you when the script is running. It's giving you some information down here. So what I've basically said is when I recognize 12 blueberries in the scene, then I want to print this line. So that's how I know that it's working. So that's really exciting. But now I actually want to, you know, kind of create more of an augmented reality experience. So what I'm going to do is my handy dandy behavior script. I live and breathe by this thing. I want to trigger that. And instead, where in the other template that was kind of set up for us is not in this one, but we can set it up ourselves. And it's really, really easy. So all I have to do is write global.behavior system. And then send, again, I'm going to use the send custom trigger ability here. And this can be anything we want, just to kind of keep it the same. Let's use found. All right. So now what I've told, and I misspelled that, what I've said to Lens Studio in this script, and it's not working yet, I'll tell you why, but what I've said here is I want to use the global behavior script, I want to reference it, and I want to send a custom trigger on found when I see that there are 12 berries, when the camera knows there's 12 berries. So the reason that I'm getting this error is because I haven't set up the behavior script in my object panel yet. So to do that, I'm going to press plus, again, I'm going to go to my helper scripts, I'm going to bring in behavior, and let's set up exactly what we want to do. So in this case, once again, I'm going to set up that I want to do a custom trigger. The trigger will be found. And the response type is I want to, like I was kind of saying, I want to make this nutrition fact kind of appear. So let me go ahead and bring in a screen image once again. Here's my default image. I have made just a quick little asset related to these 12 blueberries, where it looks like a little nutrition facts that you would see like, you know, at the grocery store or something. So here's my little preview image. It shows us serving size 1 cup is 12 berries, and then just some facts about the calorie content. Blueberries, very healthy. So I'm gonna put that on my screen image here. And that is. I'm just gonna resize it a little bit. It's not taking up the whole field of vision. And I'm going to put it in the middle here, but above my counter, so I can still kind of see that happening. And didn't mean for it to zoom in. I just wanted to rename this. Okay. I think it's really important to, these are just sort of like best practices whenever you're doing anything. Label your stuff, just so you can keep track of it a little bit easier, like tips and tricks. I know it's really basic, but sometimes we get so into it that you're just like pulling in so many things from different places, and then you get lost and you're like, I don't remember what is what. So nutrition facts. So same sort of setup as that hummingbird. I want to say the response is set enabled. So I want to set enabled my nutrition facts object when I have found 12 blueberries. All right. And let's see if this works. Let's try. It's counting 9 and then it counts 12 and it appeared. To really make sure this is working, let's do a video. Where it's really counting. This one only has 9 blueberries, so we're not seeing it. That's too many, because again, we've hard-coded it. I believe this one has exactly 12. Or no, the bowl has 12. There it is. Sorry, I ruined the moment. Very too. So as soon as it hit 12 is when it showed nutrition facts. So that's it. Super quick. We've made something happen. We've made like a kind of a whole educational experience. And, next steps, right, is I would really want to make maybe like some more functionality of like maybe it's a range of what it can detect, really wrap that up in some nice functions. Maybe, animate the way nutrition facts pops in or something, or, you could really take this in any direction. But the idea is kind of, we used exactly what we had, some of the abilities that were already built in this template, and had like kind of a, hopefully everyone thinks it was creative. I was excited about it. Interpretation of what's going on to just make a really interesting experience. So now I can imagine this could track, all sorts of different foods. And when you know what an actual serving size is, because at least for me, like I never really know actually, how many is representative of a serving size. So it could be kind of a helpful tool, and you can count the number that you're seeing and then get a little information about it. So there we go, multi-layered, multi-object detection.
Maya, thank you so much for this. I know that you packed a lot of information into today's demonstration. So for everybody who is watching, you can always come back to the stream once we finish. It's going to be posted as a video. So go back to it, pause, follow the process along. But, you've shown a lot today. And I think that you can draw a lot of inspiration and, really see how you can use pre-existing templates to create something really unique and how you can really achieve the vision that you're looking for. And again, don't be intimidated by, machine learning just because it sounds scary. Experiment with it, break things, borrow things from different templates. You can always, go to the template, go to the object panel, right click, save, like download the object and bring it into your other project too. So, you don't have to reinvent the wheel all the time to make something really, really cool. Just get into it, get your hands dirty, give it a go. And if you come up with anything after watching this stream, please share it with us by tagging SnapAR on Twitter. We would love to see whether or not this was, helpful and what inspiration you drew. Maya, thank you so much. Energeta, thank you for also being here. I know that, having you kind of break down additional concepts and being kind of our go-to person on a Snap machine learning team is a pretty big job. So we appreciate both of your times. Thank you for being with us today.
Thank you.
I'm just going to take a quick look through our chat just to make sure that we don't have any outstanding questions. Definitely had seen a lot of comments about how Lens Studio has become so powerful, and this was really helpful. Really lots of excitement and many thanks from our viewers for breaking that down. And I think we even had questions about whether or not we're going to have a follow-up on this. So we can always get a little deeper into machine learning. So if you all are interested in it, let us know on Snap's social media channels that you would like to see another stream where we dig even deeper. And hopefully we'll be able to make that happen for you. But for now, if you have any sort of last words, Maya or Geta, please go ahead and take this time. And I'm just going to scan the comment section to see if there are any outstanding last comments.
The one thing I did want to mention too that's kind of cool about using ML is you actually get a little bit more space in your lenses. So just a kind of a fun fact, when you're working with Lens, obviously, especially on a mobile platform, you always have to be cognizant that you want to make like such a amazing experience, but also you have to make sure it's going to run properly. So trying to keep your assets small, things like that. So you can always see what the current lens size is by going up to here, and it'll tell you how many megabytes you're using. Again, when I first started using Snap, we only had 4, so now we have 8. So that's really exciting. But when you are using SnapML, you get an additional 10. So just to know that that's kind of helpful. So everything's going to run properly, and you get a little extra space.
Awesome tip. And just to let both of you know, I don't think we have any outstanding questions from our viewers. But again, very many thanks and lots of excitement around what you've shown today, Maya and Argetta. Thank you so much. And if there are no more questions, we can wrap it up for the day. Thank you for your time. I hope that everybody who has watched today will walk away feeling a little bit more confident and more inspired to get into Lens Studio and try out the existing templates or do things from scratch. Thank you for being with us today, and we'll see you next time.
Thank you so much.
Bye, everybody.
Bye.